Hey there! Today I'd like to go through a brief example of how to calculate the definite integral of a polynomial. This expression here states that we're taking the integral of 4x cubed minus 2 with respect to x from x equals 1 to x equals 3. Recall that this essentially just means we're finding the area under the graph of this function between the spots where x equals 1 and x equals 3 using the method of dividing it into a bunch of tiny rectangles like I described in a previous video. In order to actually calculate this integral, we're going to want to remember that because of the fundamental theorem of calculus described in my last video, integrals are just the opposites of derivatives. This means that in order to take the integral of this expression, we're basically just going to do the opposite of what we would normally do to find the derivative. Since taking the derivative of a polynomial like this would normally use the power rule, where we would multiply the exponent out front and then subtract 1 from the exponent, in order to find the integral of this polynomial, we're just going to do the opposite steps in the opposite order. This means we're going to start by adding 1 to the exponent of each term, and then divide each term by its new exponent. In the case of this expression, we'll start by adding 1 to this exponent, meaning we have a new exponent of 4. From here, we'll simply divide the whole term by the exponent of 4, which tells us the integral of this first term is simply x to the 4th power. Similarly, for the next term, recall that negative 2 is the same thing as negative 2 times x to the 0, since anything to the 0th power is 1. From here, we'll add 1 to the exponent, creating a new exponent of just 1, and then we'll divide the whole term by 1. This tells us that the integral of this second term is just minus 2x. Now, in order to properly take this integral on the bounds given to us, we have to remember that this integral is evaluated from 1 to 3, which is typically notated using these square brackets. From here, we'll use the other part of the fundamental theorem of calculus that I talked about in the last video, where evaluating this integral from 1 to 3 is the same thing as the integral at 3 minus the integral at 1. This means we can go ahead and plug 3 into our expression here, and then subtract from it the same expression but with 1 plugged in. At this point, all we have to do is simplify, and we find that the final answer is that this integral is equal to 76.